So, mean value theorem. Remember, there are two criteria for mean value theorem. First of all, the function has to be continuous between 2 and 6. We know there's an asymptote at x equals 0, but that's not in the interval, so we're all good to go. Second would be that f is differentiable between 2 and 6, and yes, we know it's all nice and smooth and happy. All right. So what we're going to be doing is we're going to be setting the derivative. I'm just going to put the x in there. I'm going to be setting it equal to, because that's the c we'll be solving for, f of 6 minus f of 2 all over 6 minus 2. So be careful. This is not the derivative we're plugging into, right? That's a common mistake. We're going to be plugging those into the function. So if I was to take the derivative, so again, I like rewriting this. So the derivative would be negative 3 over x squared. So negative 3 over x squared. And the c I'm solving for is x, right? The c is the x value. So if I plug in 6 into the function, I'm going to go slow, 3 over 6 minus 3 over 2, and then 6 minus 2 gives me a 4. So let's go. I want to make an arithmetic mistake, right? So that's 1/2 minus 3/2 over a 4. So negative 3 over x squared. 1/2 minus a 3/2. Wait a minute, that just gives me a negative 1 over 4, right? Okay, so I'm going to cancel the negatives. And if I cross multiply, I get 12. 12 is equal to x squared. And so plus or minus root 12 is x. Okay, be careful. My x value, or the c value, has to be between 2 and 6. So I say choose just the positive one. Right, let's look at this next one. So unless you know it's one of the common ones where it's got a cusp or corner, a weird thing, you can assume that it's going to be continuous and differentiable. So between 0 and 9, it looks like, yes, I can draw it without lifting my pen between 0 and 9, right? The 0 and 9 are both in the domain. Is it true, and this is roles, remember, is it true that it's differentiable between them? Yes, because I've taken out the endpoint. So Rolls says I have to make sure f of 0 and f of 9 are the same number. If I plug in 0, I get 0. If I plug in 9, I get root 9 minus 1/3 times 9. That's 3 minus 3. That's 0. Okay, so now I want to make sure I can find the x value that makes the derivative equal to 0. So let's go take the derivative. So I get 1/2 x to the negative 1/2 minus 1/3 equals 0. So go slow, and I'm going to encourage you to write that negative exponent in the denominator. So that if I cross multiply, I get 3/2 is root x. And be careful, you're squaring both sides, right? So 9/4 is x. Is 9/4 of the x value in between 0 and 9? Yes, it is. So that's the one x value that works. Okay, so this is moving into test 3, section 1. Just taking baby steps in there. All right, so what I want you to do is rewrite that first. So this would be 10, and if I rewrite this as y to the power over root, that'd be negative 4/3. This would be minus y to the 1/2, and then this would be positive 4, y to the negative 1/3. So now to take the antiderivative, I add 1 to the exponent. So I carry the 10 along. I add 1 to that, so that would give me a negative 1/3. And I put it over a negative 1/3. Minus, add 1, 3/2 over 3/2. Plus, carry the 4, add 1, 2/3 over 2/3. And then plus c, because there's always a c at the end. Most general antiderivative, so this will give me a negative 30 y to the negative 1/3 minus 2/3 y to the 3/2 minus, this will give me a 12 over a 2, and I know you could simplify that, y to the 2/3 plus a c. So that's how you take the antiderivative